I'm gonna let you know the end from the beginning. So I'll take up this section here for exponentials, and then I'll do logarithmic underneath. So I'm kind of gonna go across the page like this. So exponential, right? It always looks like this. In general, it has it will look like this, okay? So I need you to know what the general graph looks like. Have the asymptote like this. Y is equal to 0. And so I will have one for decreasing. So it will go like this. I will label this 0A. Okay. And this is where B is between 0 and 1. I should make this like a Patreon. If you want more, for $5 you get access to the unlocked, even an interview with a special guest. And then you have the B is greater than 1. You've got an increasing scenario. Okay? This is still 0A. And if you later want to take a picture of this, that's fine. Okay? Because the domain and range is the same for either one, I will just do that here. Domain is all real numbers, negative infinity to positive infinity, right? The range is different. The range, y is greater than 0 if you want set notation, but most of you are not going to choose it. So you're going to go from 0 to infinity. So 0 is not inclusive. 0 is not an option, but you can get really, 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 really close to it. So that's why we go 0 brackets, like everything close to it, but not including 0. Okay, that's what round brackets mean. Okay. But now we're going to move into word problem. So now we have to translate it into a word problem. We have to know better than to include, oh, should I do the quadrant? Can I sneak in the quadrants real quick? And behavior. What's the end behavior of either one? Q what? Q2 to Q1. So if you rather just put a 1 and a 2 there, right? Sorry, I mixed it up. 2 and a 1. It doesn't matter. It goes from 1 to 2 or 2 to 1. It doesn't matter. Q2 to Q1, both of them. And behavior is good to know as well. Word problem, everything changes. This scenario here, right? Because your equation is gonna look the same, but they're gonna put it in a word problem. You're gonna have to find the y-intercept, and then you move towards the x-axis. Okay. Find y-intercept. That's important for your graph. Okay. Which is 0A. If you have the equation, you know what it is. Okay. This is an arrowhead. Sorry, this looks like a dot. It's an arrowhead, right? If it's an increasing function like this, Let's, it starts here and then it goes up. What else should I say here? I'm going to try to sneak in the, this is decay. This is doubling. So this is growth. So you have doubling time. Decay, you have something called half-life. Okay, that's important that you distinguish, that you know when it's talking doubling. It's talking doubling time, we're talking this scenario, half-life. Bless you. We're talking something decreasing. What should I add here? To find half-life, y2 is equal to A divided by 2. Second trace intersect. I don't know how detailed to make this. Doubling time. Y2 is also, you're going to go 2 times A. And then second trace intersect. If you can squeeze this in, this is A right here. A is determined by that y-intercept or also the equation. And so you're going to find that intersection here. Doubling time involves growth. So if this is A, you're going to double A and find that intersection there. Okay? So you're finding how long it takes to double. I don't know what to do about the domain and range here. It's going to get messy if I do that right now, so I'll leave that for now. Let's do, I still want to do this here. If you, I don't know what your space is, just fit it in somewhere for now. I will close that off. And I would say regressions. Regressions, if, you know, population doubles every 5 hours. Start with, you know, 20, let's say. You know what? You're gonna say, oh, the question. This says start with 20. Start with 20 every time. Not true. Let's do initial population. Initial population, let's go 20. So you go time, population, you go 0, at time 0, you've got 20. You add 5, so you're at 5, you double. you add another 5, you double. L1, L2, stat, calc, exponential regression. I don't think I need to do that for half-life, do I? Half-life, what would be different if it's half-life? What would, instead of multiplying, you divide by 2, right? So I'll leave that in your court. If you need to have an example of half-life, do it. You can actually turn this into half-life. You can say population goes down by half every 5 hours, and then you do it that way. Okay? This is exponential, okay? This is it. If you have your table, you make your regression, you do what you need to do there. Now I'm going to talk logarithmic here. I'm going to leave that at the top there. You can take a picture later. I'll have a tip jar right here. Okay. With an arrow. Because if there's no arrow on the tip jar, you might just throw it behind the counter, right? It's like, where do you want the tip? Oh, arrow, okay. All right. 11 minutes, okay, let's go. So logarithmic. You know what? I'm going to leave this dead spot here. I'm going to fill this in with something else later. Like, I want it nice and start from scratch here. So logarithmic. Okay. I know what I'm going to put in here if I have time. Okay. Y is equal to a plus b log of x, or y is equal to a plus b ln of x. Natural log. In general, you may have this scenario. If b is positive, I should start with negative, just like the top. Remember, I'm making my study sheet. I probably have to do this all over again, right? Erase and then rearrange. But it goes like this. And you've got your asymptote here. X is equal to 0. And then right here, b is positive. Let's do the domain and range. My domain is what? 0 to infinity. And my range is negative infinity to positive infinity. X is greater than 0. Y is all real numbers. If you look at this, guys, the range of the logarithmic is the domain of the exponential, and vice versa. So there is a connection there. Okay, word problem. This is going to go like this. Find x-intercept. If b is positive, the end behavior again. Forgot it again. What's the end behavior for the logarithmics in general? End behavior, we're going from quadrant 4 to 1 every single time. Make sure you know that you have to find the x-intercept to get you started here. And I'm going to end with the regressions, okay? I'm going to do that here. Regressions. Remember, it's always x and y. This goes into L1, L2, or and this is why I want to put this in the notes in your study sheet, because some students mix this up with lin regression, L-I-N. That's linear. You don't want that if it's a logarithmic, okay? Stat, calc, Ln regression, okay? L1, L2, Y1. Not Lin reg, okay? This would be wrong, okay? Do not use lin reg because it's going to be the wrong one. The only regression you can do is a natural regression, a natural log. I know what I wanted to add in that dead spot there that I skipped, and you can add it wherever you want, but it's exponential specific. Oh, I will say this. Time might be your y variable. That is something to note with the logarithmics. I put that bubble right here. I'll post this video, so if you have a hard time falling asleep, autoplay, right? Moving on to the top here. And it's going to be you guys are pretty amazing at compressing, okay? This dead spot here, I just want to have one. If you have y is equal to 1,000, 0.9x, this dead spot here, you know that this is decreasing. So you go 1 minus 0.9, that's 0.1. 0.1 times 100, it's a 10% decrease. On the other hand, if you have something bigger than 1 in there, it's an increase of 25%. It's per unit. So if the time, if x is time, then it's per time, and it could be day, per hour, per minute, per second, whatever x ends up being, okay? Now I know what you're asking. Oh, if I got this down, I'm set, right, Mr. Erickson? I'm done, like I'm good, right? I don't need anything else. I can't say that. I cannot promise that, okay?